Hello all, a few more questions on sequence and series. Let's do this first one. If A, B, C are in HP, then A minus C, A minus B are in. I told you easiest to take examples. I'll start with 1, 2, 3 being in AP. So, HP would be 1, 1 by 2, 1 by 3 are your ABC. So, what are A minus C, that is 1 minus 1 by 3, that is 2 by 3, and A minus B, 1 by 2. What can you say about this? Obviously, they are not in AP, they are not in GP because B squared is not AC. Are they in HP? Are they reciprocals? What are their reciprocals? 1, 3 by 2, that is 1.5 and 2. Aren't they in AP? Their reciprocals are in AP means the numbers themselves are in HP. Option C is your answer. Now, the sum to infinity of this series. Now, let's write down its general term. What is that? Nth term is, the third term is 1 by 1 plus 2 plus 3. So, nth term will be 1 by 1 plus 2 plus etc. plus n. Sum of the first n natural numbers is n into n plus 1 by 2. Now, we have done in a question before this, like partial fractions, what you can do is the numerator, this 2 you can take out, and the 1 can't you manipulate as n plus 1 minus n by n into n plus 1. Why have I written like that? Because these terms that I have introduced in the numerator are the factors of the denominator. So, what is it? 2 into, separate the terms, 1 by n minus 1 by n plus 1. Okay, that is your nth term. So, what would be your first term? It is 1 by 1 minus 1 by 2. Second term will be 1 by 2 minus 1 by 3. So, those are the terms. Let us find the sum to infinity. What is the sum to infinity? The 2 will remain outside. This is 1 by 1 minus 1 by 2. 1 by 1 minus 1 by 2. Next is 1 by 2 minus 1 by 3. 1 by 3 minus 1 by 4 and so on. So, this is 2 into these terms cancel. So, the only significant term, because as n tends to infinity you are going to tend, they are what you see are terms that tend to 0. So, what is your answer? 2 into 1, 2 is your option. Now, the sum to n terms of 1 by 2 plus 3 by 4 plus 7 by 8 plus 15 by 16 and so on. Let me tell you two ways of doing it. First of all, the direct way, you have to write down the general term. General term denominator will be 2 raised to n. 2 raised to 1, 2 raised to 2. Now, look at the numerator. Isn't it 1 less than the denominator? So, isn't it 2 raised to n minus 1? So, this is 1 minus 1 by 2 raised to n is the general term. So, what would it be? You have 1 minus 1 by 2 plus 1 minus 1 by 2 squared plus etc. Nth term is 1 minus 1 by 2 raised to n. What is their sum? These n ones will add up to n. Now, minus, what is it? 1 by 2 plus 1 by 2 squared plus etc. n terms are there in the second brackets. What is that? N minus. In the second brackets, you have a GP with 1 by 2 as a first term and 1 by 2 as a common ratio. So, what is the sum to n terms? It is A into 1 minus r raised to n by 1 minus r. So, you will have n plus 1 n minus 1 plus 1 by 2 raised to n. N minus 1 plus 1 by 2 raised to n. Option A, C is the answer. But look at it. If the options are given to you, that's a better way, I think. What is S1? Isn't it 1 by 2? Now, which of these will give 1 by 2 for S1? What S1 you will get by putting n equal to 1. The first would be 2 raised to 1, that is 2 minus 1 minus 1. Option A is wrong. Option B, 1 minus 2 raised to minus 1, that is 1 minus 1 by 2. Option B may be right. Option C will be 1 by 2 plus 1 minus 1. Option C also may be right. Option D will be what? 2 minus 1, 1, no. So, it is between B and C now. So, now check whether S2 will give. What is S2? Isn't it 1 by 2 plus 3 by 4? That is whole divided by 4. It is 5 by 4 should have been S2. But according to option B, what would be S2? 1 minus 2 raised to minus 2, 1 minus 1 by 4, 3 by 4 would have been S2. So, B also is eliminated. Option C is your answer. That is another way of doing it. Now, if A1, A2, etc. AN are in AP with common difference D, what is sin D into cosec A1 cosec A2 minus cosec A2 cosec A3 and so on, cosec n minus. So, what I will do is I will just take the first term and see how best I can simplify it. So, what is that first term within the bracket? It is cosec A1, that is 1 by sin A1 into 1 by sin A2. Okay, so this is and there is a sin D also in the numerator. Now, this D being the common difference of this AP, isn't it sin of A2 minus A1 divided by sin A1 sin A2? Expand, it is sin A2 sin A cos B minus cos A sin B divided by sin A1 into sin A2. Separate the terms, sin A2's will cancel, you will have cot A1 minus cot A2. Now, in the same way you can predict the next term, which is cot A2 minus cot A3. So, cot A1 minus cot A2. Next is cot A2 minus cot A3. Similarly, all the terms, last term would be cot of An minus 1 minus cot An. Look at the terms that cancel. These two will cancel, these two will cancel, these two are going to cancel. You are just left with cot A1 minus cot An. Option C is your answer. Now, if S1 SS is 1 squared plus 3 squared plus 5 squared plus 99 squared, then the value of the sum, which is 2 squared plus 4 squared plus 6 squared plus etc. plus 100 squared, is what you have to find. Now, you have to make use of the sum that is given in your question to evaluate this sum, right? So, look at this, sum in your question is 1 squared, 3 squared and all. So, this 2 can I write as 1 plus 1 the whole squared, 4 is 3 plus 1 the whole squared plus 5 plus 1 the whole squared plus etc. plus 99 plus 1 the whole squared. Now, expand a plus b the whole squared, which is a squared plus 2ab plus b squared. So, from each of these brackets, group the first terms. What are the first terms? 1 squared plus 3 squared plus 5 squared plus 99 squared. Isn't that your S in your question? Plus. Now, group the second terms. What are they? 2ab terms. So, 2 into 1 plus 2 into 3 plus 2 into 5 plus etc. 2 into 99. So, take a 2 out to get 1 plus 3 plus 5 plus etc. plus 99. Now, the 1 squareds, how many 1 squareds are there? Aren't there 50 terms? All those 50 ones will add up to 50. So, this is S plus 2 into, look at the term within the bracket, isn't it an AP with how many terms? 50 terms. So, 50 n by 2 into 2a, that is 2 into 1 plus n minus 1, that is 49 into 2. plus this 50 here. So, if I simplify, this is s plus 50 into 2, if you take out, you have another 50 plus this 50. So, if you simplify, your answer would be 255 A plus 2550. Option A is your answer. Now, sum the series 1 by 3 plus 1 by 15, 1 by 35. Basically, if you get the format of this, it is easy. I think terms like 35 and 63 should give you the clue. What was 35? What strikes you when you see 35? 5 into 7. 63 would be 7 into 9. So, you know the format now. It is 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9 and so on. What is it that you observe? All these, the denominator differ by 2. So, let us introduce the 2 by dividing outside by 2 and multiplying inside by 2. Now, how do I rewrite this 2 in each? You write it as the difference of the terms in the denominator. 3 minus 1 by 1 into 3, 5 minus 3 by 3 into 5, 7 minus 5 divided by 5 into 7 and so on. So, this is 1 by 2 into, separate the terms, 1 by 1 minus 1 by 3. Next is 1 by 3 minus 1 by 5. Next is 1 by 5 minus 1 by 7 and so on. So, these terms will all cancel. So, what are the terms that remain? 1 by 2 into 1, 1 by 2. Option A is your answer. Now, sum of the first p terms of the sequence is this. If you actually put the value of p, you will realize that this is not an AP, not a GP, nothing. Okay, but yet you are asked to find the sum, the 10th term of the sequence. Isn't the 10th term of a sequence equal to, you need, see, you have, this is the 10th term. Isn't the 10th term sum to 10 terms minus sum to 9 terms? So, 10th term is S10 minus S9. What is S10? Sum to 10 terms is 10 into 11 into 12 minus 9 into 10 into 11. So, 10 into 11, that is 110. If I take out, what will remain? 12 minus 9, 3. So, 330. Option D is your answer. Now, sum of this sequence. Here the problem is the bases are not the same. So, always you have to try and make the bases same. So, which is the property of logarithm that I am going to make use of here? It is log of a to the base b is 1 by log b to the base a. So, basically if such a term has to be brought to the numerator, you just have to interchange these two. So, that the terms here is now going to be log 2 to the base 4 plus log 4 to the base 4 plus log 8 to the base 4, log 8 to the base 4 plus etc. log 2 raised to n to the base 4. That is given to be, that is what you are asked to find. So, this is log to the base 4, 2 into 4 into etc. 2 raised to n. So, this is log to the base 4, this is 2 raised to 1 plus 2 plus etc. plus n. This is log to the base 4, 2 raised to n into n plus 1 by 2. This is log of 2 raised to n into n plus 1 by 2 and 4 is 2 squared. Now, how do I proceed? Log of a to the base b, c to the base d is b by d into log a to the base c. This is a property of logarithm. Log a to the base b, if the base is c to the base c to the power d, you will have b by d into log a to the base c. So, if I apply that property here, you will have n into n plus 1 by 2 and divided by 2. That is into 1 by 2 into log 2 to the base 2. that term is 1. So, what is your answer? N into n plus 1 by 4, option D is your answer. Now, if alpha and beta are the roots of this equation, gamma and delta are the roots of the second equation, alpha, beta, gamma, delta form an increasing GP. Okay, so what is given? So, alpha is alpha itself, beta I can write as alpha into r, next is alpha into r squared, alpha into r cubed. Okay, so these are your alpha, beta, gamma and delta. What is given? Alpha and beta are the roots of this. So, what is the sum of the roots? Alpha plus alpha r is 3. What is the product? Alpha squared r is a. In the second, what is the sum of the roots? Plus alpha into r cubed is 12 and alpha squared r raised to 5 is b. Okay. So, from the first equation, what do you get? Alpha into 1 plus r is 3. From this equation, what do you get? Alpha r squared into 1 plus r is 12. If I divide these two, alpha into 1 plus r will cancel, r squared is 4, r is plus or minus 2, but it says it's an increasing GP, so r is 2. Now, if r is 2, what is alpha? Substitute r is 2 here, alpha is 1. So, you found the values of alpha and r. What are you asked to find? A and b. Okay, what is a? It is alpha squared r, 1 squared into 2. A here is 1 squared into 2, that is 2. What is b? Alpha squared r raised to 5, that is 1 into 2 raised to 5, that is 32. So, so 2 and 32 are the values of, so option C is your answer. Now, in a GP of positive terms, any term is equal to the sum of the next two terms. So, any term, for example, A is the sum of the next two terms, that is AR plus AR squared. Divide throughout by A, don't you have R squared plus R minus 1 is 0? So, this is a quadratic, what solve? R is minus 1 plus or minus root of B squared minus 4AC, isn't that 5 divided by 2A, that is 2. So, these are all positive terms, so you can neglect the negative R. So, what is the R? It is root 5 minus 1 by 2. Now, you know root 5 minus 1 by 4 is 8, is sine 18. So, this 2 if I write as 4 here and into 2 here, and this value is sine 18. So, what is the value of R? Isn't that 2 sine 18? Option D is your answer. Now, this one, if 1 squared plus 1 squared by 2 squared plus all that, that is infinity, then what is 1 squared by 2 squared plus 1 by 3 squared plus 1 by and so on. Okay. Now, what you have to find if I call x? So, the given question I can divide into two parts. One is 1 by 1 squared plus 1 by 3 squared plus instead of x maybe s plus 1 by 5 squared plus so on plus 1 by 2 squared plus 1 by 4 squared plus so on. Okay, that is given to be pi squared by 6. Now, isn't the first bracket what is asked? So, can't I write that as s? Now, from the second brackets, what can I take out? Can't I take a 1 by 2 squared, that is 1 by 4 out? What will remain? 1 by 1 squared plus 1 by 2 squared plus etc. up to infinity. Now, what is this value? Isn't that pi squared by 6? So, this is pi squared by 6 also. So, what is s? It is 1 by pi squared by 6 into pi squared by 6 into 1 minus this also pi squared by 6. So, pi squared by 6 if I take out 1 minus 1 by 4. Pi squared by 6 1 minus 1 by 4, that is pi squared by 6 into 3 by 4. So, pi squared by 8 is your answer. Let us see if that is an option. Yes, option C is your answer. Yes. If the sum to n terms is this, again as before I will give you the direct and the shortcut method. Okay, what is the general form of this term here? Isn't it n into n plus n into n factorial? Isn't that the general term here? So, this can't I write as this n, can't I write as n plus 1 minus 1 into n factorial? So, I group this and then open the brackets. Isn't that n plus 1 factorial minus n factorial? So, the general term is this. So, what is the first term? Put n equal to 1. Isn't it 2 squared, 2 factorial minus 1 factorial? Second term is what? Second term will be 3 factorial minus 2 factorial, then 4 factorial minus 3 factorial and so on. So, the nth term will be n plus 1 factorial minus n factorial. What are the terms that cancel? So, what is your answer? N plus 1 factorial minus 1 factorial, that is this. Now, let us look at a smarter way. Okay, what is sum to one term? It is just 1. Which of these gives 1 as sum to one term? If I substitute n is equal to 1 here, isn't it 2 factorial minus 1, 2 minus 1? 1 is the answer. So, option A may be right. What about the next one? 1 minus 1, 0 factorial minus 1, minus 1, no. Option B is wrong. Next one, 0 factorial plus 1. So, 1 minus 1, that is 0 factorial plus 1. So, option C may be right. What about option D? 1 plus 1 factorial, 2 factorial plus 1, option D is wrong. So, it is between A and C now. So, now what about sum to two terms? According to A, what would be your answer? 2 plus 1 factorial minus 1, 3 factorial minus 1, that is 6 minus 1, 5. And here also you know 5 is the answer, but what about here? It is 2 minus 1 factorial, that is 1 factorial plus 1, 2 would have been the answer. So, you are eliminating C also, option A is your answer. Now, sum to 10 terms of the sequence. Now, what kind of a sequence is this? Isn't this an AP? Because common ratio is the same, second by first, third by second are all equal to root 3. So, what is sum to 10 terms in a GP? A into, that is root 2 into r raised to n. So, root 3 raised to 10 minus 1 by r minus 1. Isn't that root 3 minus 1? So, you have root 2 into, this is root 3 raised to 10 means 3 raised to 5. So, 273. 273 minus 1 is 272. 242. 243 minus 242 divided by root 3 minus 1. So, I factorize by multiplying by root 3 plus 1. So, what do I have? Root 2 into root 3 plus 1 divided by 2 into 242. Yeah. So, what is it? So, 2 goes in this. So, root 2 into root 3 plus 1, root 2 into root 3 plus 1 divided by 2 into 242. 121 into root 6 plus root 2, option A is your answer. Now, if A, B, C are in AP, so 2B is A plus C, P, Q, R are in HP, so 2 by Q is 1 by P plus 1 by R. This in GP means B squared, Q squared is APCR. Okay. So, what is given? so just let's substitute here. What is B? From here, isn't it? No, this is P plus R by PR, and substitute those values here. B is A plus C by 2. So, A plus C by 2 the whole squared into B is that, what is Q? It is 2 PR by P plus R, 2 PR by P plus R the whole squared, that is APCR, APCR. So, the 2 squared and 2 squared will cancel. So, you have A plus C the whole squared into P squared R squared is equal to APCR into P plus R the whole squared. So, P and R will cancel. So, what do you have? So, A plus C the whole squared divided by AC is P plus R the whole squared divided by PR. Yes, because no, what is it? So, you have A squared plus C squared plus 2AC PR into PR is equal to AC into P squared plus R squared plus AC PR. So, these will cancel. So, what do you have? You have A plus C, A squared plus C squared by AC is P squared plus R squared by PR, that is P by R plus R by P, which is your question, is A squared plus C squared by AC, which you separate, you will write as A by C plus C by A. A by C plus C by A, option A is your answer. Now, the number of terms common to these sequences. So, what you do is, first find the term, the smallest term which is common to both these. Isn't that 21? So, there is a 21 which is common to this. How do you find the next term which is common? What you do is take the LCM of the two common differences. What is the common difference of the first? It is 4. Common difference of the second is 5. Their LCM of 4 and 5 is 20. So, that common difference you keep on adding to get the resultant AP. So, 41, 61 and so on. Now, this is a term which which has to stop with maximum, it can be 417 only, no? Because, so in such a term, how many terms are there if 417 was the last term? You have 417 is 21 plus n minus 1 into 20, in which case you will get n minus 1 as n minus 1 as or n is n minus 1 into 20 is 6, 11, 9, 396. So, n minus 1 is 396, that is 198 divided by 10, that is 19.8. So, n will be 20.8. It has to be less than that. So, how many terms are going to be common to all these? It is 20. Yes. If the sum of the roots of this quadratic equation is equal to sum of the squares of their reciprocals. So, what is given? Alpha plus beta is minus b by a, that is alpha squared plus beta, sum of the squares of their reciprocals, sorry. So, it is 1 by alpha squared plus 1 by beta squared, that is minus b by a is alpha squared plus beta squared by alpha squared beta squared? Isn't that alpha plus beta the whole squared, that is minus b by the a the whole squared, that is b squared plus a squared minus 2 times c by a, minus 2 times c by a divided by alpha squared beta squared, isn't that c squared by a squared? So, cross multiply, you have minus b by a into c squared by a squared is equal to b squared by a squared minus b squared by a squared minus 2 times c by a. Now, you can cancel throughout by a, you have minus bc squared by a squared is b squared by a minus 2c. Multiply throughout by a squared, you have minus bc squared is ab squared minus 2a squared c. Rearrange to get all positive terms, you have 2a squared c is ab squared plus bc squared. Now, divide throughout by ABC. What do I have? 2a by b is ABC. So, a and b will cancel. B by c plus c by a. So, what do you notice? That these, that is b by c, a by b and c by a are in AP. Is that option given to you? No. So, what is given? Their reciprocals, that is c by b, b by a and a by c are in HP. That is your a by c, b by, and c by b are in a by c. Yes, are in HP. That is your option. Option C is your answer. So, with that we come to the end of this MCQ on sequences and series. Thank you.